Simon. My introduction. Well, there's probably enough on the slide for you to see there. I have a fair number of hats, one way or another. I've been in the industry for 45 years, something like that. Um, Best part of 30 years with Arup before setting up my own. Came from an engineering background. But having said that, um, architectural engineering was a dominant background aspect. So I've got links into the ROBA, being an honorary fellow and so forth. But enough about me, because what I want to talk about today is to introduce you all to a new publication which has come out of a LETI workstream. It's why existing housing? Well, existing housing is by far the largest carbon emitter in the building sector. Um, it's as frequently evidenced, UK has some of the worst housing stock in Western Europe, with the implications in fuel poverty and social issues, what have you. And this guide, the LETI workstream thought would be a useful way of re-examining how we do retrofit given the current situation. This is but a whistle-stop tour, but all the details for downloading it are provided. It's free to download. So I'll be covering what I mean by a retrofit standard, why retrofit has such a low policy priority in the UK, the scale of how much we have to do it, the need to join. It's a wicked problem. It involves top down and bottom up. We will need to change how we do retrofit, but also we need to look at how we rearrange the funding, for example. The aim, looking at a halving of heat demand, but for doing it for about 65% less cost than a normal deep retrofit. And this is the re-evaluation of fabric systems and productivity. Absolutely key is productivity, and a little bit on lessons learned. But so where did this all start? LETI published the Climate Emergency Retrofit Guide, which looked at best practice. A lot of useful stuff in there, good case studies and so on. One of the elements of feedback was we can't afford best part of 80,000 per home. What's the option for wider housing than just best practice? And that's where LETI set up a work stream with the remit of looking at how many homes, how deep, and at what cost. The cost thing was very interesting in what that threw up. And this is the document now published. I have to say, first of all, a big thank you to all the LETI contributors, the workstream and other contributors. There's about 80 of them. We were in 7 workstreams plus reviewers and so forth, examining how far do we need to go on fabric, and then the systems within the building, looking at the costs, looking at social aspects. Why does a typical householder not want you to go and scramble your house up, their house up and their home up? And also a fundamental review of Climate Change Committee and their recommendations on how we get to zero carbon. One thing which I'll come back to later is these are all individuals. They're taken out of their day jobs as volunteers to talk as individuals without the vested interests of potentially the day job, whether it's a supplier of heat pumps or whatever. And this has meant some rather different answers to the usual answers, but I'll come to that later. So why does retrofit have such a low priority? Well, fundamentally, the data suggests that it is 3 times more expensive to save carbon by retrofit than to build more wind turbines. That is where we're starting from. The Climate Change Committee's 6th carbon budget suggests we only need to do a 12% home efficiency improvement and switch to a grid. to the grid. So fundamentally, national policy priority is not on retrofit. We have a lot of wind potential. If you look at it in a little more detail, and I won't go through it all, but it's here if you want to have a look at it later. CCC says we should be able to, as a country, get to zero carbon for 2050 for 1% of GDP cost. So what is 1% of GDP? Well, per home, and we've got roughly 28 million homes, it is 36,000 per home. So when we talk about a retrofits of 80,000 per home, you can see the numbers don't stack up. You can see the government, as we know, having lack of money, is going to circumnavigate that one. And ultimately, you also look at the way the bills, gas bills have jumped over the last 3 years. They're just short of twice what they were 3-4 years ago. If you add up that extra all the way between now and 2050, that also equates to almost 1% of GDP. Now, that does not bode well given the number of people in fuel poverty, which are having problems paying their bills at the moment, let alone the fact they're having to pay for the whole of the UK to then get to net zero carbon or the equivalent. So what's the scale of the issue? We know retrofit has a role, but at the moment, we're barely scratching the surface. The Social Housing Decarbonisation Fund, and yes, I know the new government's changed its name, but it's historically, you can see its contribution to the whole housing stock. If you look at Passive House Trust, Enefit Standard, ACB, Energy Strong, all of those are doing brilliant work at the best practice end. Look at the scale of the issue we have still yet to address. The social work stream identified a whole raft of blockers, which mean for most householders, they're not really thinking about this. It's too expensive. One of the key things we found was most householders regard their homes as space constrained. There's no way you can go in and grab a large space for a hot water cylinder to allow a heat pump to be put in. We need to be offering other technical solutions to address some of these concerns. The level of disruption, the idea we're going to insulate the inside of your home or the exterior, and we're going to spend 2-3 months doing it. No, most households are not going to go there. Yes, social housing providers can look at when the voids occur and so forth and so on, but for the vast majority, that is inappropriate. And one could go through all of those kind of headlines to find we are not offering something which your householder would be prepared to accept. And this wicked problem illustrates the issue. There's blockers in a whole set of different locations, and we need to be able to work through all of them to make sure they're all working together. We've seen with the Green Deal, if you only hit some of them, you miss on the other, it doesn't fly. So the idea of changing how we do retrofit, putting the costs down, being able to do it quickly, we're looking at 7-day retrofit, and the document talks about how you fit that in. The idea then that means the limited manpower, tradesmen and so forth, can do a lot more retrofits, for example. But we also need to provide guarantees on the energy performance of what we deliver. A lot of the potential finance is limited because there's no guarantee you'll get what you are. At the moment, everybody, you hear a lot of words about, oh, well, put in a heat pump, you save your bills. You don't, comparing a new boiler with a heat pump, because the energy used by a heat pump costs you 3 times more than gas at the moment, for example. So we need to be honest and provide guarantees, because the end householders or the portfolio holders don't believe the numbers. And this then also works at the other level when we begin to look at where there is funding available. For example, if you're reducing demand for energy, that allows the supply side to only need smaller capacity. Smaller capacity on our grid, when we have to increase its size, it is big money that we can potentially save. To look at this for example, just a snapshot gives you an indication. The pink part of the graph is existing electrical demand across the year, fairly uniform. The blue is if we just switch over to heat pumps. So there's a good efficiency in there. There's 250, 300% efficiency. But the capacity of the grid has to go up almost 2.5 times to deal with the peaks. That's a lot of money for a grid which is not used for 2/3 of the year. The idea of reducing the peak demands in our existing housing by potentially 25% smaller grid capacity needed if we retrofit our homes frees up, for example, £90 billion, which can be redirected into retrofit. Those are the sorts of things one's looking for to try and fund retrofit. It's great when you hear people saying BRE's done excellent work looking at the savings to the National Health Service if we had a good housing stock. But you have to say, are we going to get any of that money to pay for the retrofit? NHS is so desperate for money. The fact we may save them some money, that money is going to stay in the NHS. It is actually not a potential funding stream for retrofit, although it is a nice soft benefit you can use to argue for. Another cost opportunity is looking at our productivity. This is data, I think it's Nesta published this from other data, national data, and it shows our productivity, and that's the green line at the bottom, has hardly changed in 30 years. Whereas the red line at the top is manufacturing side of things has almost doubled over that period, productivity. There is considerable scope to improve how we do a retrofit to provide a better service for our consumers. And part of this involves understanding from other industries how they've examined where to put costs. This is a cost quality curve. And you can imagine on the right-hand side, there's Enefit, there's the Passive House Trust. Brilliant way of doing retrofit. You pay for it, but you get exactly what's on the label. That's one extreme. On the other end, you could say building regulations, minimum standard. No one checks actually how it performs afterwards. They just tick a box that something's been installed. And then you end up paying extra on energy bills and so forth and so on. There's talk about often being 40, 50% extra energy compared with building regulations predictions. So where's the sweet point in the middle? How much can we take elements of best practice from Passive House and start applying them at a more modest level to try and get the best of both worlds? And lo and behold, I jump on a bit. We found a new cost sweet point, a sweet spot. Taking the most dominant housing type in the UK, looking at halving the heat demand for 2/3 less cost, and a whole set of things which allowed us to do this. And there's a list here you can go through in more detail, but understanding the property in the first place, the number of measures put in without understanding your property, even putting in your heat pump. Who's done a proper sizing because at the moment, well, I'll come back to that, we're potentially oversizing by as much as 100% in some occasion, and very often by 50%. Have a retrofit plan which identifies the appropriate level of retrofit, because not everybody wants the all singing, all dancing. So where do they want to pitch it? The idea of looking at the fabric, how far do you go? Well, there's a interesting sweet point, which is to do with just enough fabric first, so you don't need to touch internal surfaces or the radiator system or any of the radiators. What do you have to do sufficient to allow those radiators to be able to operate with a heat pump with the lower temperature it delivers to the radiator and still deliver enough heat? And then systems terms, the idea that we need to make sure there's a basic level of ventilation, given the amount of mold this is now beginning to become apparent in our housing stock. Looking at alternative kit, and I'll come into that in more detail, verification that it's actually installed, air tightness testing, and balance the systems, and then monitoring afterwards, doing HLC tests, thermal tests, or effectively using the metered data afterwards to provide warranty that you're delivering what was on the can. In cost terms, this was a real eye-opener. The cost work stream identified, for example, that typically about 40% of the cost of retrofit disappears into overheads. There's duplication all over the place. White van person turns up after the previous work is done, when in reality, we normally look at the commercial world sector, parallel working for a considerable number of these. And how do you manage people's involvement so they can do that parallel working? But also things like just replacing all the windows can be 14 grand a house itself. Whereas we identified we could potentially reduce from about 65,000 down to about 18,000, the cost of doing what would be regarded as a pretty deep retrofit. And just a snapshot on the fabric side. For example, I mentioned the windows. You can have your hinges replaced on your existing double glazing, because something like 90% of homes in the UK have double glazing. The benefits of replacing the double glazing are fairly modest, but it's a big cost. But actually spending 700 quid on replacing all the hinges so that they then settle back onto the gaskets to give you air tightness, which they've lost over time. And so you'll find most of these are relatively light touch methods, and more importantly, quick to apply measures. And there's also things, for example, on the top right, external wall insulation. There's a dramatic difference between the cost of doing a flank wall compared with a front wall. Flank wall, you don't have all those silly details around every window, and you don't have to do battle with the local planning department because there's historical features on the building. And actually, a lot of householders rather like the look of their house after they may have bought it or rented it or whatever element of choice in there. So we have found that restricting the external wall insulation to the bits which are more cost effective to do actually made the process a lot simpler. And just to give you an idea on the services side, the right-hand side is what we as an industry love to show: beautiful pipework and large storage vessels and large heat pumps. Is that what the householders want? Actually, most people who are not the eco warriors and whatever just want something which delivers heat and warmth and so forth and so on. So we spend a lot of time looking at how can you replace the heat pump without taking a square inch of internal space, and realize if we use a thermal store, that's a heat battery, a phase change, which costs you 50% more than a typical cylinder, but allows you to fit into the space vacated by your combi boiler. And by the way, your pipes are already there and you're reusing the radiators, so you don't need to touch that. The electrics are there, controls are there. Oh yeah, and you've got a hole through the wall no longer used by the flue for taking your pipes to your air source heat pump immediately outside. And by the way, it's half the size because you've reduced the demand by half. But I have to say the products aren't necessarily there. You can get a thermal store, but they're floor mounted ones for the big retrofits, large detached sort of things, or high rise. There's been examples where the idea of tailoring them in size so that they fit in to make the process of installation a lot better and make it allow you to bring householders along, because they're not having to lose a room or part of a room in their space constrained homes. So the aim was to go down to that level of detail of showing how you can quickly install a heat pump instead of a boiler. And indeed, ventilation became a key issue because one of the big energy gains was air tightness. And it's a bit hit and miss whether trickle ventilators work. And actually, a lot of the double glazing out there doesn't have trickle vent. A lot of homes have just had the windows installed and haven't thought where the air supply goes in or the ventilation. So, and there is issues of humidity. Ultimately, we felt the idea of putting in a simplified MVHR, mechanical ventilation heat recovery unit for the whole house, was an essential part of providing a robust package which the supply chains could then install. We identified targets of no ductwork below floors, because very often they're picked up, no separate plant rooms needed, and looked at how we could integrate ductwork largely in the hall spaces, use the staircase in the corners for risers. What kind of products would you use to make that look neat and tidy? Looking at nozzle diffusers over the door for blurting the air across the room. And then even as basic as we should have these 10mm gaps below all our doors, whatever ventilation system, natural or MVHR. But the industry doesn't have a tool for cutting off 10mm off a door without having to take all the door off and chip away at that paint in the hinges. Those are productivity components where we are currently short of the products that we need to deliver the increased productivity we need, the speedy turnaround. And then I mentioned funding. We looked at how much of the sector we think will be best practice, exemplar practice, and 2/3 of it still at this more basic level. We then looked at where the funding would come across the whole, with the full mix of those at a national level, looking at elements of able to pay, but also what I was talking about, the national grid savings, supplementary tax, a couple of percent on if we're saving energy, the wind turbines have got spare energy to sell abroad. We've in the past been an exporter of coal, oil, gas. We have so much potential wind offshore as an island in the Atlantic compared with Netherlands or Austria or what have you. The idea of being able to sell that and then take a little slice of tax, 1 or 2%, when currently oil and gas has something like 30%. I think they've recently increased it. So we're enabling a capacity of wind turbines to become an export benefit for the UK. Can we have a small slice, please? And we've taken some energy savings, but actually most householders only look at 3 to 5 years max. And the social rented sector, is very different way as well, and needs a different approach of making sure that they're upgraded, potentially using an eco extension. But read more about that in the guide. And I'm going to finish a few lessons learned. One, EPCs now have smart data measurements, real numbers, and you see a dramatic difference between those. And the worse the buildings are, allegedly, the worse the difference is. Therefore, the basis of doing a retrofit based on EPC data is thoroughly flawed. And indeed, it has to be said that if you look at the meter data, the numbers don't change a great deal, irrespective of the ABC, whatever. And therefore, are we measuring the right thing when we're looking at what delivers energy savings? And therefore, there is a need to do more comprehensive surveys, particularly air tightness tests, and so forth and so on. But typically, your radiators, we're looking at reusing without replacing. Typically, they're oversized. Most of them were a little bit of a rule of thumb as to how they were put in the first place. And lo and behold, they were put in a size bit bigger, and they've rounded up to the next manufacturer's size. There's an awful lot of spare capacity, which we need to understand where that is to make sure that we can then judge how much fabric first we need to do to minimize the overall cost. I mentioned heat pumps oversized. The graph on the top right shows MCS, which is a standard method of sizing a heat pump, against PHPP, SAP, and then dynamic modeling, which is from the commercial world, how you measure thermal inertia, internal heat gains, dynamic half-hour interval modeling for the year. And we find MCS is almost double the capacity. And it's even worse when you put in the hot water. And we've identified in the middle there on the right is conventional sizing. Actually, your heat pump's being asked to go on and off all day using the MCS sizing, largely based on a hot water recovery period. But if you can change the controls, so you recover a certain amount of the hot water at intervals, because we don't drain a hot water store all in one go, and then you run the heat pump almost on the coldest day for most of the hours of the day, you then find you can potentially halve the heat pump size, which then means we can more likely to put it into those space constrained homes, the ones which don't have a large garden and so forth, or on the wall over the corridor going above the corridor at the end, a passageway at the end of the terrace sort of thing. We also, looking at the moisture side of things and the fabric, realize the real benefit of MVHR. And this graph simply shows that warmed air into your bedroom where you dry your clothes or whatever it is going to pick up more moisture than the current preferred in building regulations, central mechanical extract ventilation. Simply because it's warmer, it can remove more moisture. And this allows a more robust solution. If you say, right, we're providing that in all of these homes, it allows you to provide a minimum level of background ventilation. No fancy humidity control to vary the speed. This is just fit, commission, and leave. And all it needs is a filter change, ideally like your smoke detector prompts you when you want a battery change, for example. Do we have those products here? No. If you go to other countries, they're there. China, when I worked there, we were speccing these basic units, and there must have been production of millions. They have a certain air quality issue out there. So we were putting these in most of the apartments, for example. These are an alternative to the all singing, all dancing, which are great for the top end of the market, but struggle for the mass market. And finally, one needs to touch on overheating. Uh, as soon as you said we're removing the need for the bypass, summer bypass on the MVHR, people say, oh, no, you need that for overheating. If you look at the numbers, they're almost irrelevant as a contribution to overheating. Here we have on the left analysis for during the day, and compare it with a ceiling fan, for example, and you find it is far more effective cost terms. Users understand it to install ceiling fans. We need to learn from countries which have already got 1.5 degrees temperature higher than ours, what they're doing, and not necessarily listen to a supply chain which just wants to sell us large amounts of additional cooling capacity, for example, mechanical. So ultimately, there needs to be a reality check on where we want to put our money, and the all singing, all dancing isn't necessarily the best solution for all of us. So some quick takeaways. Industry needs to counter the wind is cheaper policy mantra. Well, hopefully you get an idea that this document looks at how we reduce the cost of retrofit to make it comparable with wind. And then we've got all these social benefits and so forth and so on. It then follows up. But this needs top down and bottom up parallel thinking. Policy looking at the supply grid, where the money goes, reallocating investment so that we retrofit every home, but without increasing the costs for the UK getting to net zero carbon. And the selling angle, we're using low tech energy reduction solutions as opposed to largely unproven big technology energy supply side solutions, the hydrogen, the carbon capture and storage, and so forth. There's an awful lot of quick wins that can be made by demand reduction. But we do need something which is an identifiable standard for all. People can rely on. The idea of halving heat demands for 65% less cost. We will need simpler products, as I mentioned. Simpler means cheaper, simpler processes, and aim for big productivity gains. If a heat pump installer can install 3 times the number of heat pumps, that is what we're after. We must respond to the householder and those social drivers. If the householder doesn't let us over the door threshold, we ain't going to get any retrofit done. So the idea of one-stop shop, 7-day turnaround, past 2035 process, fully warranted and guaranteed performance. We're not used to that, but this is what consumers now expect. If you want to know more, download Retrofit-at-Scale. Happy to take some questions.
Brilliant. Thank you very much, Chris. Well, that was fascinating and very succinctly sort of put across.
Bit of a rant at a certain level, but yeah.
Yeah, I mean, I particularly like the whole concept of coming up with retrofit that looks at a more sort of realistic or certainly significantly reduced cost. But before I get into a number of questions that I know I could ask you and would like to talk through, I think it would be good to we've had 1 or 2 questions already coming through in the chat, so maybe we can start to put those to you. What would be great is if people like to come off mute as I mention your name, and perhaps you can put your question direct to Chris. So the first question came from Pete Marsh. If you're there,
yeah.
Pete.
Hi, Pete. And I see a question. Yeah, are you going to recite
let's
the
see
question, or I can look in the
let's
chat?
see if Pete can come off mute and just sort of
great.
put the question in his own words. You there,
Hi,
Pete?
Chris. Yeah, can you hear me?
Hi,
Yeah,
Pete.
we
Yes.
can.
Great stuff. Yeah, thanks for that, Chris. Really, really informative. I looked at the document as well. It's really good, really good stuff in there. I just had a quick question on some of the fabric measures with
Yep.
the 7 day turnaround. And the first one was kind of just a clarification, really. So the ground floor insulation that's predominantly then for suspended floors. I'm assuming.
Absolutely accept that. We looked at the stock model. We looked at the most frequent uh, housing types, and we focused on that. And we realized, although it's more costly sometimes than um, lifting your floorboards and insulating in a different way, using the little remote control spray underneath with the appropriate checking process, gave us real benefits. And not least of all, it's the front living room, because the top floor, you're insulating in the roof, no problems. The ground floor, to try and halve the heat demand so that you can retain the radiators. The air tightness is very important, which one mentioned fairly extensively, but also there's an awful lot going through the floor. Now, if you have solid floors, looking at a comment, yes, there are alternative ways of doing it, whether it is less insulation thickness on top of a solid floor, or whether you go down the outside with external wall insulation, what have you. We're not redefining the measures, we're defining what the objective of the collective fabric improvements are. I hope that sort of gives you a little bit of a pointer.
Yeah, it does. Thanks, Chris. And then just the second part of that was just on the thermal bridging kind of kit of parts in
Yes.
terms of is that basically really just the window reveals? Is that
It we looked at these in a fair amount of depth and realized it's one of the reasons for going for MVHR, if to try and reduce the risk of the thermal bridges, which you will be left with.
Mhm.
But in the past, thermal bridges didn't create condensation. It's when we start shoving insulation around them that
Right?
we're and making it more airtight. So we wanted to address that at a moisture ventilation level. But the idea of bathrooms and so forth, we came up with what we suggestions to us of neat little tricks on the way of doing reveals, insulating the reveals in a using standard products, um, which allowed us to deal with some of those occasions. For example, the bathroom is the obvious one where you often have a fair amount of condensation.
Great. Thanks, Chris.
That's brilliant. Thanks for that, Pete. The next questions come from Richard, if you're available to come off mute, and that's quite an interesting question, so I'll let you put it across.
Yes, I believe you've got quite an interest in bricks, haven't you?
Well, in the sense the housing stock is has an awful lot of brick in it. Admittedly, it's stone if you go north of the border and things like that. But anyway, carry on.
Yeah, so a recent retrofit up in Broxtowe
Yeah.
is they didn't use pre-manufactured brick slips or sheets of brick slips.
Okay.
They got someone to just sort of carve brick patterns into the concrete render,
Yeah.
and it doesn't really look like what it once looked like, shall we say. I mean, if you go to that link and go down a bit, you'll come across the pictures,
Yeah.
and the brick sizes are all over the shop. But it sort of brings to light the skills of people doing retrofit and some of the shortcuts that people will perhaps take. And they'll
Indeed,
just they'll just throw up
I
piece
take
of
your
steel.
point. I don't think necessarily those solutions will see the fullness of day when it comes to other people wanting to do it. And indeed, one of the reasons for not looking at insulating externally the front wall was very much that, because I don't suppose any of them are actually doing Flemish bond as opposed to English bond to suit the age of the house, for example. But ultimately, this report isn't trying to say yes or no to those solutions. It's just saying there are solutions out there that we need to be exploring in more detail. But
And
I
what you
would
just,
go away and look at that link in more detail because I'm intrigued.
you know, and what you said earlier about airtightness, I mean, I'm glad you did go on to speak about mechanical ventilation, the heat recovery afterwards. But I believe the two should always be mentioned simultaneously at the same time,
Uh,
because
yeah,
without
absolutely, absolutely.
the mechanical ventilation heat recovery, the ceiling is just going to cause massive condensation.
Absolutely. Pass 2038 absolutely reinforces that. We have to be in accordance with that. So absolutely agree. Thank you.
Brilliant. Thank you very much, Richard. That sort of leads us quite nicely on to Alex Clifford, who's actually posed a couple of questions. But Alex, if you'd like to come off mute and maybe put your first question initially around heritage properties.
Yeah, I kind of actually had a lot of questions, but I'll try and avoid the detail and keep that high level stuff really. And it was
Thank
on
you.
one of the tables, it was showing the split of retrofit works, and it had 2% heritage. And I assume that's listed buildings, but there wasn't
Not necessarily, but yes, carry on.
So the question really is that I kind of am led to believe that it's nearer 25% of housing stock is kind of vapor open housing stock and is actually in the difficult to treat kind of area rather than the 2%.
It's a valid point. What we worked with the people in ACAM who did the conservation guide. And the reason we did that was our original, the LETI original retrofit guide had identified about 25% that were heritage constrained, not necessarily specifically vapor open construction. And the ACAM work looked at actually most of these, for a lot of them are simply in conservation areas or not, and so not individually listed. But even when you talk to English heritage and so forth and so on, they're talking about being able to do a fair amount of these kind of interventions because they're not so visible. So the 2%, looking at have a look at the report and you can see the logic behind that. And yes, those 2% will need a different way of looking at it. The vapor open is being bandied around as a yes or no thing, when in reality, all buildings at one level or another are vapor open. Your solid wall building is allows vapor to go through. And that's where it's so important to make sure you keep the ventilation humidity level relatively low on the inside so you can always get that moisture flow inside and extract it, particularly when you're doing internal wall insulation. But that's one of the reasons we decided not to go for that and simply look at the external because the risks are less in moisture terms. But absolutely agree. A retrofit assessor needs to identify which methods are most appropriate for your building.
Yeah, that kind of leads on to my next question, but I don't know if it's picked up now or later on.
No, go ahead, Alex. I think you're right.
So I'm a passive house designer. I've been working in the construction industry for 30 odd years. I'm also a retrofit coordinator, and I'm doing my retrofit assessor course, and I've done retrofit assessment of older buildings, qualifications, and things. So I'd say I'm pretty well qualified. I've done all the courses. The bar's really low. If you're a qualified retrofit coordinator or retrofit assessor, you don't really know what you're doing. So when everything is based on PAS 2035, it's a bit of a worry if you're then going at scale to have people with very little experience who can go out and lead these works. And there's already been, I don't know if people are kind of on the same LinkedIn kind of pages as I am, there's a number of cases of PAS 2035 wall insulation jobs where they've already got dry rot and they're from certified SWIP systems as an example. So it's a bit of a worry when you try and do that at scale when the bar's so low on the qualifications.
Well, I acknowledge what you're saying, and it is unfortunate that the previous government even looked at dumbing down past 2035 to have a more basic trust mark thing. So I absolutely recognize very much what you're saying. But I think somehow we need to work out how we have a more basic level for the mass of the stock, not the specialist ones. And yes, you're absolutely right to highlight you need someone with experience who can identify, yes, you can do the basic retrofit here, or you need additional input and you're going to have a more specialist team working on this. We are in transition. If we say everyone's got to be passive house certified, for example, and that's the gold standard, there's absolutely no way we'll do 28 million homes.
No, my point on that really is it fits in with like the underfloor installation on a Victorian suspended floors. I've pulled up a lot of floorboards in a lot of houses and had a look, and most of them, or they nearly all, have very poor cross ventilation or no cross ventilation, and lots have damp problems. So to then have someone who's underqualified saying go and spray it with a robot is a bit of a worry.
Without going into, as you say, too much detail, the idea of, and I don't like to quote suppliers necessarily, but the idea of doing the insulation with an aggregate certificate system like QBot or whatever, in which they are obliged to test the moisture conditions in the space above, the space below, the timbers, check the ventilation is adequate below, because you're absolutely right. So many people have just covered up the ventilation, is essentially part of retrofit. We need to get more people to understand that does need to be done. So thank you for that, pointing that out.
All right, thank you.
That's great. Thanks, Alex. Yeah, and I think for me that underlines quite an important issue of the sort of on-off debate about are we retrofitting or not, does it work or not, is we as a nation certainly need to move on, in my view, from the idea of shall we do this or not. We need to do it, so therefore we need to acquire the skills, we need to set the standards and so on. And as in many instances in the past, not to do with sustainability, we found that we when we need to, we're actually very inventive and we're very good at sort of driving through change.
A little bit of a learning curve, isn't there? I
Yeah.
look at the heat pumps, which is part of the field I deal with a lot, and you look at the misinformation which is circulated, particularly on social media. Oh, they don't work at low temperatures. Finland's got more of them than ever we have, for example.
Completely. Yeah.
These things we need to work through, and having more tradespeople who understand these and who can put the arguments is actually part of this equation, because at the moment it's social influencers talking to social influencers, as far as I can see. We need to get influence from social influencers, don't we?
Yeah, I think that leads on nicely actually to Angus's question. So Angus, if you're on the call, perhaps you'd like to unmute and...
Yeah, hi, how's it going? Yeah, pretty much sort of that we kind of came onto that. That's one of the main things. I deal a lot in heat pumps as well. And so that sort of misinformation about whether it's suitable, there seems to be a lot of inconsistency from installers on measures. So, we frequently hear from homeowners that have been, different heat pump installers or retrofit installers have told them different things about the same property. And they don't really know where to look or who to trust. And when you try to advise those people, it's very difficult to say, you can start to go through the assumptions that these people have made and point out where the flaws in their things are. But it's not easy from a homeowner point of view of knowing where to look and what to do.
And who to trust.
Yes, exactly. So I don't know how we clarify that or make that easier.
Well, one of the things the guide talks about is setting up local community-based initiatives to do retrofit. So people can talk to each other, householders, portfolio holders and so forth can talk to each other, and you build local teams. You know, my PV, I had someone from Penrith come down to install, and I'm thinking, why am I paying for this? And you find the inefficiencies in the process are often addressed if you can use local tradesmen who are trained up, they're working within their community. You get good rapport with the enablers as well, who then can provide the appropriate information to the householders, because everybody is being just inundated with information. A lot of it is so commercially biased as to be almost irrelevant. And you know, when did you last have a heat pump installer come along and recommend you ought to increase to 300 millimeters the insulation in the roof because it allows me to have a smaller heat pump put in a heat? He's not going to do that. It's not in his interests to offer smaller kit. He gets a smaller profit, sort of thing. So fundamentally, we do need to move away from individual trades operating in isolation to provide the and instead provide the one-stop shop with all of the skills there, so you can get a coherent, balanced story.
Cool. Yeah, that makes sense. I'm aware of there's one in York, actually, Your Energy, that are doing that type of thing, and they seem to it seems to be a nice solution, but I don't know how frequent that is in a lot of different areas.
We need the good case studies. You then to have them disseminated so that others can then pick up on it. But there's an enormous demand out there which is not being met at the moment because we're not offering a retrofit service in the right way.
Yeah, I think there are some, there's a great case study or example with what John Christophers, who many of you may know, has led in Balsall Heath, where they have that community-led approach. And I think you're right. I think there's that sort of level of knowledge share, but also importantly, trust in the process. When a whole street or a whole neighborhood is engaged, you start to understand and actually weed out the things that aren't working well or are inappropriate just through conversations. I think we don't realize as citizens how much power and knowledge we have collectively to influence these things if we're going to go ahead with them. Excellent. Well, we're sort of coming to the end of time, Chris. So I think it's probably an appropriate point to say thank you again for sharing your thoughts and the work that's been going on. As I said at the end of the talk, I think the idea of this, if you like, retrofit sort of light approach of making something accessible and realistic for a majority of homeowners and at a significant reduction in cost, I think is really important. So thank you very much for sharing that. I'm certainly going to take the opportunity to read the guide now in a bit more detail, having had an introduction, and wish you well in continuing with it.
I've put in the chat the link to the download of the document.
That's brilliant. Yes. Well, I'm sure I won't be the only one who's choosing to pick it up. So,
great.
Yeah.
Thank you very much for all of you attending.
Yeah.
Thank you, Simon.
Thanks all. Bye.